All right, so this class we're going to continue working with absolute value. Hopefully by now you're comfortable with the definition. If you're not, I'm just going to quickly go over it once again just to refresh your memory. Okay, so the goal of this class is to solve absolute value equation. So now we're going to be doing algebra with it. Okay, so last class you were just simplifying, so you're just doing arithmetic, but this class you're going to actually do some algebra. Now, don't worry about the graphing aspect, okay? So the textbook actually, I don't know, shows you how to graph the absolute value first before showing you how to handle the algebra, but I think I'm gonna just show you the algebra first before I show you the graph. Okay, so the graph we'll talk more about that next week. So recall, right, the definition of an absolute value. I know it's seems like a very complicated definition, but in plain and simple English, what this means is that if the x value inside your absolute value happens to be positive, right? If it's greater than or equals to 0, then the absolute value does nothing to that x value, right? Because it's already positive. Remember, the absolute value always changes a negative number into a positive number, right? But if it's already positive, then it just leaves it like that, right? Then you get x back. But if your number is negative, right? If the number inside your absolute value is negative, then your absolute value function, um, yeah, it's actually a function, right? So your absolute value function actually attaches a negative sign to it because that negative sign will turn the negative number into a positive number, right? Because two negatives make a positive, okay? So that's basically the definition of an absolute value, okay? So if the number inside is positive, then it remains the same. But if it's negative, right? If the number inside your absolute value is negative, then you have to attach an extra negative sign to it to make it positive, okay? So now the question becomes, right? Your starter question is, um, if I gave you this equation, right? Absolute value of x is equals to 7, and I ask you the question, what values of x will satisfy this equation? Okay, so I want you to solve this equation. Okay, absolute value of x is equals to 7. What are the possible values of x that will make this equation true? Okay, and some of you might just say that, let's just think about this, right? Some of you might say that, well, if x is equal to 7, right? If x is equal to 7, then this equation will be true because absolute value of 7, right? Because it's already positive, remains 7, right? So, which is what we have up here. So that is one of your solutions. But just like a quadratic function, this actually has another solution, right? The other solution is, um, some of you might have guessed it, right? What if x is equals to minus 7? If x is equals to minus 7, then the absolute value of x will be the absolute value of minus 7, which also gives you 7, right? So both of them work out, right? But now the question is, how do you find the solutions? This is kind of like, we were able to guess the solutions, right? Which is a decent technique, but eventually your equations will be more challenging, right? So basic algebra you can get away with guessing, but how do you do this in a more mathematical way that will always work? Okay, so what's the logic over here? What we have to do is we have to rely on the definition. Okay, so we're gonna have two cases. So this absolute value actually splits into two cases. Okay, case one is what you have on top. So maybe let me just do this in red. Okay, so this is your case one, and this will be your case two. Okay, so we're gonna rewrite the absolute value as a linear function. Okay, so case one is when um, x is greater than or equals to 0, right? So if x is greater than or equal to 0, then absolute value of x, actually, you know what? I have to be consistent with my color. Sorry about that. So case one in red, right, is when your x value is greater than or equal to 0. So if your x value is greater than or equal to 0, then your absolute value can be, um, you can use your absolute value basically is x, okay? For so right, your absolute value when you Okay, so how should I say this in plain and simple English? Basically, when x is greater than 0, then the absolute value does nothing to the number that's inside the absolute value. Okay, so I'm just using case 1. So case 1 tells me that if x is greater than or equal to 0, then absolute value of x is actually equals to x. So instead of writing absolute, so you have absolute value of x is equals to 7, right? But because x is greater than or equals to 0, I can replace the absolute value of x by x. Okay, so I'm going to rewrite this as x is equal to 7. Now there's nothing to solve over here, right? So, right, remember when you're doing algebra, your goal is to have x all by itself. So this is your first solution, okay? And once you find your solution, always check if it's within your domain, right? It's if it's within the, if it's not it should not be one of the values that's restricted, right? So in this case, if my answer was x is equal to -7, I would have to reject that because I am assuming that all my x values are greater than or equal to 0. Okay, so that's kind of like the tricky part. Okay, so once you find your solution using algebra, always check if you're within your domain. Okay, if you're not, then you'll have to reject this value. In this case, I am, so I'm going to accept this. Okay, so this is case 1, and now I found my solution. Now case 2, right? Case 2 is when this is my case 2 over here. Okay, so case 2 will be this when x is less than 0. So if x is less than 0, then absolute value of x is equal to 7 can be rewritten as minus x, right? Because minus x, because x is less than 0, is equal to 7. And when you solve for x, right, I mean, there's many ways of doing it, right? One way would just to switch the signs, or if you want, you could divide by -1, divide by -1, right? So these will cancel out, so x will just equals to -7. Okay, so this is your second solution, and this is how you do it. Okay, so you start off with the initial equation, but your case restriction, right? Your case will tell you how to treat your absolute value. If x is greater than or equals to 0, then your absolute value is actually going to be just x. If it's less than 0, then your absolute value will have to be replaced by -x. Okay, so it's kind of like you will always have to do this in two cases, and then you will find your solution. Okay, so it's kind of tricky. So I hope this is kind of making sense, but we're gonna practice a little bit more. And I'm going to give you a lot of time this week to practice on this. Okay, so again, this is a confusing concept. Okay, so it just takes a while to really um, understand how absolute values work. Okay, and even um, I remember when I was in high school, it wasn't something that came to me very easily. It's a very tricky concept. Okay, so in this case, I need to solve for this equation. Okay, so the first thing that you need to do is write your absolute value. Okay, and now split this into two cases. Okay, the first case will be whatever is inside your absolute value stays the same. So you're gonna have 6 minus x, and this will be true, right? If whatever you have inside your absolute value is positive. So in other words, if 6 minus x is greater than equal to 0, right? If this stuff inside your absolute value is positive, then the absolute value will do nothing to it. You'll get the same thing back. But when you do this, okay, um, make sure you're always solving for x. Okay, so make sure you're solving for x. So if I solve for x, then I get, right, so maybe yeah, I'm kind of running out of space, so I'm just gonna rewrite this one more time just to show you why it's important to solve for x. Okay, because you need to know what your domain is. Okay, so there are two cases, right? The first case is you get the same thing back. Whatever you have inside your absolute value, you get the same thing back, right? And this will be the case, right, if whatever you have inside your absolute value happens to be greater than or equal to 0. If it's positive, then you get the same thing back, right? So if you solve for x, I'm just gonna put or, and then I'll just solve for x, right? Just move the x over, or however you want to do it. When you solve for x, you're gonna see that x has to be less than or equals to 6, right? 6. Okay, so focus on this. Okay, this is kind of like your domain. Now, the second case is write the same thing that you have on the inside up here, okay? But make sure you multiply this by a -1, okay? So in that case, you have to put brackets, okay? Because the minus will have to apply to the 6 and to the minus x, okay? So this is your second case, right? So second case is whatever you have inside 6 minus x, you have to multiply that by -1 if what happens to be on the inside is negative, so strictly less than 0, okay? So you don't have to put the equal sign here, okay? You only have to put it up here, not down here, okay? So you could if you wanted to, but just yeah, just I think it's just better to just leave it up there, okay? Now, in this case, if you solve for x, okay, it's going to be exactly the same thing as this, except your inequality will be flipped, and it won't have an equal sign, okay? So x has to be greater than 6, okay? So these are your two cases, okay? So let's kind of break this down one more time, okay? So, right, I'm just using the definition of absolute value. So absolute value of 6 minus x will remain the same, right? Your absolute value function will do absolutely nothing to it as long as the algebraic expression that you have inside is positive, okay? As long as it's positive, it will remain the same. But if it's negative, then you have to attach this minus sign, okay? So you just have to understand the definition. Now, again, make sure you're solving for x, okay? It's super important to solve for x because sometimes you will have to reject your solutions if they're not part of your domain, okay? So now let's do this question on a case-by-case basis, okay? So let me just clean this up, okay? So case one, right? So case one is when x is less than or equals to 6. If x is less than or equals to 6, then absolute value of 6 minus x equals to 2, right? I'm going back to the initial question. Will be 6 minus x is equals to. It's the same as that. Why? Because of my definition, right? Over here. Using this fact, I can replace this absolute value by this expression, okay? In case one, okay? So which is what I'm doing over here. And all you have to do now is just solve for x, okay? So if you solve for x, again, I'm not going to take too long. So x will just equals to move 4, okay? So you guys solve it however you want. I'm just not gonna take too long to solve a simple linear equation. Okay, case two is maybe let me just do this in blue. Okay, so case two is when uh, your x value is greater than 6. So if your x value is greater than 6, then um, I think I'm gonna run out of space, but it's fine. So this is the initial question is equals to 2, right? So you have to replace this absolute value by this stuff over here, okay? So you have this will become that. And then if you solve for x, here I'm going to work you through this because I want you to do this the fastest way possible. Now, one way would be to distribute the minus sign over, right? And then solve for x, which is what you can do. It's fine if that's the way you want to do it. Or if you want, you can just get rid of this -1 right away. Just divide by -1, divide by -1, right? So this will turn into 6 minus x is equals to -2. And if you solve for x, you're going to get x is equals to 8, okay? Because you're going to have to do +2, +2, and then +6, +6. Okay, so these are your two solutions, okay? X is equals to 4, x is equals to 8. But once you find your solution, always check if they're within your domain. So is 4 less than or equals to 6? Yes, it is. So that means there's no issue, okay? Now, is 8 within your domain? Because sometimes they won't be, okay? So is 8 greater than 6? Yeah, yes, it is. So that means there's going to be two solutions over here, kind of like a quadratic function, okay? And to check your work, what you have to do is just plug in these values in the initial question, okay? So I'm not going to do the checking, um, but you can do that, okay? So replace x by 4 over here. Okay, I'm just going to, I guess, do this just with you mentally, right? So 6 minus 4 is 2, and absolute value of 2 will give you 2. Now, 6 minus the other solution is 8. 6 minus 8 will give me -2, but absolute value of -2 will be 2. Okay, so both of them do work, and they will always work as long as they are within your domain. Okay, so make sure your solutions are within your domain. Okay, so a slightly easier question that I want you to do that is on your textbook. Okay, so this is given to you on page 382 if you would like to see how it's done, step-by-step solution, you can do so. But these are your answers. Okay, so x is either equals to 10 or x is equals to -4, which is kind of like I have, right? So x is either equals to 4 or x is equals to 8, okay, in my case. So you're gonna have two solutions over here, okay? So try this out. Okay, again, you're gonna have to start off with the definition. Okay, so let me kind of like do this for you. And again, if you're confused, just look at that page. So I'm just gonna do the definition for you, right? So you have a absolute value of x minus 3, right? So we're gonna split this into two pieces, right? The first piece is whatever you have inside remains the same, right? If this stuff happens to be greater than, so x, sorry, the entire thing, x minus 3 is greater than or equals to 0, right? So just solve for x, or if x is greater than or equal to 3, okay? Right, and then this stuff needs to get multiplied by -1 if it's negative, okay? So if this stuff is less than 0, and then just solve for x, so for x less than 3, okay? So once you solve for x up here, the other one will be the same thing. It's just that, this inequality will be flipped, right? And you won't have an equal sign. Okay, so you don't have to solve for it twice. Just solve for it up here, and the other one will be kind of like just, the opposite of what you get up here. Okay, so you don't have to solve it twice, but basically you're going to use this definition, split this into two cases, and then find the solutions, and then you're going to find these two solutions. Okay, so either x is equals to 10 or x will equals to -4. Okay, so work this out. It's super important. Now this is an example where you have an extraneous solution. Okay, so remember we had extraneous solution with the radical equation. Okay, so it's going to be the same case with the absolute value function. Okay, so you'll have to um, check your work, okay, but as long as you know are within your restriction, you will be easily able to see which solution you need to reject. Okay, so basically, right, the first step is to, because it's hard to work with absolute value, so we're going to have to split this into two linear equations. Okay, so absolute value of x plus 5, right, is x plus 5, right, it remains the same if whatever you have on the inside happens to be greater than or equals to 0, right? And if you solve for x, which you should, because that will give you your domain. So as long as x is greater than or equals to -5, so let me just clean this up because again, I'm running out of space. So if x plus 5 is greater than or equals to 0, right? Or right, if you solve for x, which basically means as long as x is greater than or equals to -5. Now, this stuff on the inside, right, will you'll have to attach a negative sign to it. So make sure you're putting your brackets, okay, because the negative sign has to apply to everything on the inside, right? So you attach a negative sign to make it positive if the number on the inside happens to be negative, right? If it's less than 0, okay? So if it's less than 0, or, right, now I'm just going to look at this guy, and I'll just flip my inequality and write it this way, okay? So these are your two cases, okay? So case one, case one is, right, again, this is super important, okay? So make sure you're using this. So case one is when x is greater than or equals to -5, okay? I'm assuming that x is greater than or equals to -5. So if that's the case, then this question, right, absolute value of 5 4x minus 1 can be rewritten as just x plus 5 is equals to 4x minus 1, and then just solve for x. Okay, so just move your variables on one side and your numbers on the other side. Okay, so I just like to keep my variables on the left, so I'm just going to move this 4x over, right? So you're going to get x, um, or maybe let me just show my steps just to be, so minus 4x, right, minus 4x, and then this one I'm going to do -5 minus 5. So this will cancel and this will cancel. So all my numbers will go to the right and my variables will come to the left, okay? So then you're going to get minus 3x is equals to minus 6. And if you solve for x, right, you have to do divide by minus 3, divide by minus 3. So then x will equals to 2. Okay, once you find this solution, check if it's within your domain. So is 2 greater than or equals to negative 5? Yes, it is, right? So if it's, then that means that this is good, okay? The solution is good. Now let's break this into the second case. Okay, so case 2 is when this one over here, when x is less than negative 5, okay? So when x is less than negative 5, then that means the number on the inside will be negative, so I have to attach the minus sign to it, right? So I'm going to replace the absolute value by this, okay? So let's do that. So I'm going to replace, so this is the initial question, right? Absolute value of x is equals to 4x minus 1. I'm going to replace that with minus x plus 5 is equals to 4x minus 1. Again, you have the option to distribute the minus sign and then simplify, or you could just divide by minus 1. So last time I divided by minus 1, this time I'm just going to distribute, okay? So just to give you show you two ways of doing it. So this just becomes minus x minus 5 is equals to 4x minus 1, right? So what you could do is you could solve for x. Again, there's many ways of doing it, okay? So again, you could either move all your variables to the left and numbers to the right, right? Or the other way around. So however you want to do it, okay? So this time, I guess, again, I'm just going to be consistent with what I do, right? So I like to have my variables on the left. It's just a habit, okay? So minus 4x, minus 4x, so this will disappear. This would be plus 5, plus 5, okay? So then this will disappear. So minus 4x minus 4 is minus 5x, right? And this is equals to 4. And if you divide this by negative 5, divide this by negative 5, then you're going to get x is equals to minus 0.8, right? So is minus 0.8 less than minus 5? No, it's not, right? It is not, so you're going to have to reject this one, okay? So this one will get rejected. Reject this one, okay? And now just check if, if you're right. So plug in x is equals to 2 on both sides, right? So in here and also in here, and then compare the two answers. Okay, so if I plug in x is equals to 2, I get 7 here, and I'm also going to get 7 here. So as you can see, this one works. Now, what about if I plug in minus 0.8? So if I plug in minus 0.8, I will actually need a calculator for this. So just give me 1 second. Minus 0.8 is obviously not going to work. Okay, so let's just do this up here, I guess. So I'm just checking. So minus 0.8 plus 5, right? So that's minus 4.2. And the absolute value of 4.2 will just be 4.2, okay? Now, if I multiply 4 by minus 0.8, 4 by minus 0.8, and then I subtract 1 from it, so 4 times negative 0.8, and then minus 1, gives me minus 4.2, okay? So as you can see, it's not, they're not too far off, right? One of them is positive 4.2, the other one is negative 4.2. But that's not the same thing, right? The sign has to be the same. So that's why you have to reject this one, okay? So one way to figure out which option you need to reject is just by checking, kind of like what you did with radicals. The other way would be, and the easier way would be to just look at your domain, okay? Look at your restriction and see if this value is within your restriction or within your domain, okay? If it is, then it's good. If it's not, right? In this case, it's not, right? So minus, here, all your numbers have to be less than minus 5, right? So minus 5.1, minus 5.2, minus 6, those ones are good. Minus 0.8 is not less than minus 5, so you'll have to reject this one. Okay, so there's only one solution. So this one is your extraneous solution, right? So if you want, this is your extraneous solution. Okay, extraneous, I think, solution. So that's the value that you have to reject. I hope this is kind of making sense. Okay, so um, again, right, this is on page 384. But if you work this out, you're gonna get these two solutions. You'll have to reject this one because it will obviously not be within your domain. But even to convince yourself further, what you could do is just check. Okay, plug in x is equals to 0 on both sides, and you'll see that you're gonna get 5. Well, you're going to see that you're going to get the same thing on both sides. In this case, it happens to be 5. I just did that. Plug in x is equals to 5. You're not going to get the same thing, okay? And and again, there's many ways of knowing which solution to reject, right? Either look at your domain or just double check by plugging it in, okay? Now, the final case is when there is no solution, okay? And you have to be careful. So sometimes there will not be a solution. Why? Because the question wouldn't make sense. Okay, so in this case, okay, whenever you have an absolute value question, I guess I should have pointed this out. Your goal is to have your absolute value all by itself on the left side equals to something, okay? So make sure when you get a question like this, make sure you're solving for your absolute value. Make sure you're isolating for that so that you can apply the cases, okay? So in this case, I need to get rid of this 12. So I'm going to do minus 12 on both sides, okay? So then this becomes 3x, absolute value of 3x minus 4 is equals to 9 minus 12 is minus 3. But you see here you have a problem because remember, by definition, when you take the absolute value of something, the result of that will always have to be positive, right? 0 or greater than or equals 0 or greater, right? So your result has to be positive or 0. It cannot be negative, okay? So in this case, you have an absolute value equals to a negative number. That makes no sense, right? Because by definition, what absolute value has to do is to change the number into a positive number, right? So that's why there's going to be no solution over here, okay? So whenever you get absolute value of something equals to a negative number, you can just stop here and say no solution. Okay, no need to break this into the two cases. You're just going to be wasting your time, okay? Kind of like when you have x squared is equals to a negative number, okay? There's not going to be a solution over here because whenever you square a number, right, your result will always be positive, okay? So it will either be 0 or greater than 0. It cannot be negative. So just like quadratic functions did not have solution, um, absolute value functions also don't have solutions, okay? And for the very same reason, because whenever you square something, it automatically becomes positive, okay? And whenever you take the absolute value of something, it has to be positive. So if you go back to the previous questions that we did, right, let's just focus on the very first one. You see, this one, the absolute value of x was equals to a positive number. So that's why we had solutions, okay? In this case, the absolute value of this was equals to a positive number, so we had two solutions, right? No problem. And it's the same thing for the other questions as well, okay? So let me just erase this, right? Same thing for this question. And this question is kind of tricky because this is a linear function. This will sometimes be positive, sometimes be negative. So this is not an issue. If there was no 4x, if this was just equals to minus 1, then this question would have been really easy to solve because I could have just said that there's no solution, okay? Because my absolute value is equal to a negative number, okay? So make sure you, again, as you can see in every question, your absolute value is isolated, okay? It's all by itself, and then you have something on the right hand side, okay, which is what you want to do, okay? So make sure you have your absolute value all by itself before you start applying case 1 and case 2, okay? So just keep that in mind. So for homework, right, this is a tricky question, tricky unit. I want you to do as many questions as possible, okay? I'm only uploading 2 videos this week, So Wednesday is your free time. Thursday, I want you to, if you have any questions, join me during my office hours. Now, question 2 in your textbook is asking you to solve this graphically. Just do it algebraically. Okay, don't worry about graphing it just yet. We're gonna, you know, address graphing next week. Okay, so just practice with the algebra first, and then graphically you will see why we have two solutions. Okay, and just to give you, for those of you who are curious, the absolute value, as you can see, kind of acts like the quadratic function, right? You tend to have two solutions in most cases. Um, or you have no solutions, okay, because it's very similar to a quadratic function. Okay, so remember, a parabola looks something like this, okay, and an absolute value function looks like this. Okay, so you have two straight lines. So that's why, sometimes you're going to have two solutions. Sometimes you're not going to have any solutions because there's not going to be an intersection. Okay, so everything will make more sense when we start graphing. Okay, but let's not worry about that just yet. So do these questions, and I know that this is going to be tricky. So if you have, if you're running into any issues, send me an email, or join me on Thursday during my office hours. Okay? Other than that, I think that is it for this week. Thank you so much for, watching my videos. I hope this is kind of making sense. If not, please don't hesitate to send me an email. Okay? Take care, guys. Bye.